Hi, my name is Paige Weil, and I'm here to talk about a program that we've been the program that we've been implementing in Colorado called the Colorado Airborne Snow Observatory. And it's specifically a rollout of an existing technology across the state of Colorado. Again, my name is Paige. I'm with Linker. My company website is linker-intel.com. And three of my co-authors, Jeff Deans, Lorna Katz, and Taylor Winchell, couldn't be here today, but there's a great project team that's been working really hard over the last year to make this happen. So we're going to go over a few basics. What is ASO, or Airborne Snow Observatory? The problem we're facing that our program is trying to address in Colorado, our CASO planning project and some of the activities there, and then the vision and future activities we see in the years to come. Some of the graphics you're seeing here are how planes can be used to measure snowpack depth and conditions through spectrometry at the top, and then the bottom right is the results from an airborne snow observatory LiDAR flight showing snow depth over a mountain range in Colorado, and the left is showing when some ASO flights happened in Colorado in the watershed above Dillon Reservoir, which is one of Denver Water's watersheds, and specifically when those flights corresponded to existing measurement systems like SNOTEL. So first off, what is ASO? So the Airborne Snow Observatory is one of the few products to operational SWE and albedo on a high resolution scale. It's airplane-based LiDAR, where an airplane will fly over a basin during a particular time of the winter and take precise LiDAR depth measurements of the snowpack and compare those against snow-free flights that have been flown in summers previous or have been processed through other LiDAR collection efforts to get a precise snow depth. Field monitoring and snow density modeling is done to calculate the snow density. The albedo is also measured through surface spectrometry, and the combination of those three things can get you not only an accurate measurement of remaining SWE in the snowpack at a very precise scale, but also other conditions that can lead to understanding the snowmelt dynamics. This program is very, very efficient and has been commercially rolled out, and in Colorado, we're trying to roll it out to cover a wide area of the state. And why we care. So typically, SNOTEL measurements are the gold standard in Colorado for how snowpack is measured. The maps at the bottom left are the basin above Dillon Reservoir, which is the gray sort of blob at kind of the top center of this basin. And the red dots are the existing SNOTEL sites. So all estimates of the snowpack for Dillon Reservoir are based on measurements of those four locations and some assumptions, some modeling assumptions around what those measurements translate to in terms of overall SWE. You notice how between April 19th, which is around peak SWE, and June 24th, which is when melt is starting to complete, you see that the snowpack is almost gone, and many of these SNOTEL sites are reading zero snowpack remaining. So you can see the elevations, the top right graph, you can see the elevations of those SNOTEL sites relative to the measurements of SWE at each elevation band above it. And especially once you get into June 24th, the sort of orangish box plots, you can see that there's quite a bit. The vast majority of the snowpack remaining in the basin is above where the SNOTEL sites exist, which is further reflected in the bottom right graphic showing the SNOTEL sites report that the entire basin is melted out, and yet there's a significant amount of snow remaining. Through these more precise measurements, we can improve forecasts and optimize reservoir operations, which is something Denver Water has been funding for a number of years. But our program is about rolling out ASO statewide. So there are a number of agencies. So the current state of ASO in Colorado is that about 30 flights have been conducted over the last 7, 8 years. But they're targeted for specific clients. They're lacking in consistency, except occasionally they'll get flights again and again in the same basin. But there's no effort to make them broader for a useful group, to make them useful for a broader group outside of the agency that's paying for it, which makes sense. But we feel that we as the CASO team feel that there's a broad application of this technology if it can be rolled out on a widespread basis for all of Colorado. So the map on the bottom right shows that the blue coverage is where ASO flights have happened in the past, and the gray represents the median April 1st and May 1st snow coverage. So there's a lot of room to grow in terms of major metro areas that can be served, and the bulk of the snowpack of Colorado that can be measured if we are able to expand this program. And generally our goal is to develop, the goal of the program we're presenting today is to develop and communicate a roadmap for creating an equitable and sustainable ASO program in Colorado that benefits a wide range of stakeholders, especially those that can't afford or wouldn't have any interest in paying for an ASO flight themselves. Generally, our approach has been to come at this from all sides. We want this to be scientifically defensible, but at the same time equitable. So we understand the hydroclimate science of how ASO and water management in Colorado works. We've done a deep dive into Colorado stakeholder needs. We have practical experience through Denver Water and a number of other agencies' application of ASO, and we have shared learning from interviews with other states that have similar programs, specifically California. Through our project, we engaged with about 70 different agencies. We had a robust stakeholder group that met once a month throughout the summer and throughout spring, summer, and then fall this year. We started these with a series of educational sessions just to help people understand what ASO was, what existing technologies are out there, how it can be used in practice, and what are the next steps, how to make it useful once you have high resolution snowpack measurements like this on an operational basis. How can you actually improve your decision making? Specifically what we're targeting. So our stakeholder engagement program, first, as I said, involves education on what ASO actually gives you once you get a flight. We wanted to understand California's ARSS, or Airborne Remote Sensing of Snow program, which is essentially what we're trying to duplicate for Colorado, but specifically it's for a number of basins on the west slope of the Sierra Nevadas, and we wanted to understand the parallels with Colorado. And then solicit feedback from our stakeholder group. So when and how do water users make their decisions? That could be anybody from a reservoir operator down to an NGO who does annual planning decisions. What sectors actually use ASO already in making their decisions, and how can we educate people enough to where they can use it? What's a fair and equitable way to allocate flights, both in terms of location, so basins that should be covered, as well as timing. Water management decisions are typically time critical. You need to time them right around when you have the best sense in your crystal ball of what's going to happen in the runoff season to come. So how do you time those flights in a way that people can actually use it to make the best decisions possible? And what else is valuable in an integrated snow information product? Are there other things that come out of this that would really benefit you as a stakeholder? And we solicited this feedback through a 30-question survey, through the series of presentations I showed you, a 30-question survey, and then a series of focused one-on-one interviews with key stakeholders like Denver Water and a number of other reservoir operators around the state. As part of this, we reviewed California's ARSS program. We're building our program from the ground up. It started with nothing except for a few agencies funding flights on their own, and we wanted to roll this out on a statewide basis. California, the bottom right is the winter and spring measurements conducted in California. So it's about 12 measurements done across the state at specific timing relevant to the reservoirs downstream of these in these basins. The left side shows the map of the basins that were actually flown. And then the top right is just the organizational structure. And while it's important to understand the hydroclimate science, the governance and structure is also an important aspect of what we were trying to do. Our survey results, we had great engagement in our survey with over 70 responses from a wide variety of agencies representing everybody from public safety to the consulting field, academia, to state and local governments. And there was a wide range of results that came back on how would more accurate information like that provided by ASO improve their, what would that improve about how those agencies made water management decisions. And so this is just one slice of some of the results. It was a 30-question detailed survey, including a number of open-ended responses. But generally, there were having more confidence in seasonal planning and seasonal runoff forecasts would allow a lot of stakeholders to optimize their water management decisions, improve their regional planning, understand climate change impacts, and improve the flexibility of their system operations. Overall, we developed a vision that this is a very simplified version of the vision, but we're implementing a vision to promote both the funding aspects, the governance and structure, the hydroclimate science, and the water management and decision support applications of a Colorado-wide ASO program. So this planning project was focused on understanding what stakeholders need, understanding the science, and then coming up with the roadmap to actually promote that statewide and make an effective program. The ultimate goal of this is to have regular ASO coverage on at least peak SWE, so that'd be April 1st, as well as throughout the runoff season. The map at the bottom left shows what April 1st coverage looks like for Colorado, with the black line being the 10,000-foot contour. And it's a huge amount of the state. There's a lot that needs to be covered. The SNOTEL plot on the right shows that peak SWE is typically centered around April 1st, but we'd like to roll this whole program out to be able to get this kind of coverage, as well as coverage in the period where most of the snowpack has melted off. And this year's activities have culminated in a number of funding requests to promote this program further. This includes some snow-on flights as well as some snow-free prep flights. So as I mentioned before, the LiDAR differencing method that is used by ASO is based on, first, a high-resolution set of LiDAR data that captures the bare ground well. So all of the orange areas in this map are areas that we'll use existing LiDAR products or fly new LiDAR to actually collect that snow-free data in preparation for future years of measurement. And then the blue and green areas are areas that will actually have snowpack measurements this year. And this is our first year. 2022 is our first year to really promote the program and start to grow the base of flights and help our stakeholders understand the utility. Specifically in the top center of the map, the Willow Creek, Granby, and Fraser drainages are upstream of the Colorado River Basin, which in the state of Colorado is one of the most highly managed river basins. Also below that, the South Platte above 285 section, the sort of blue horseshoe, is in the source area for Denver water. So if we can get effective measurements during runoff season, prior to and during runoff season at those locations, we feel like we can help our stakeholders understand the value of this program and help grow it in the future. So this is our first set of activities and just a status update on where this program is as a whole. So with that, I'll let it run for another 10 seconds.